If you pass or reach the limit of your device's storage, several things will start to happen, generally impacting its performance and your ability to use it normally. 1. Storage full warnings. Your device will start displaying frequent notifications and warnings indicating that storage is critically low or full. 2. Inability to save new files. You won't be able to take new photos or videos. You can't download new apps, games, or updates. You can't save new documents, music, or other files. You might not even be able to save attachments from emails or messages. 3. App functionality issues. App crashes. Apps may crash frequently or unexpectedly. Failure to launch. Some apps might refuse to open. Slow performance apps will run very slowly, as they often need space for temporary files, caches, and general operation. Updates fail. Apps won't be able to update, potentially leading to security vulnerabilities or loss of new features. 4. System performance degradation. Sluggishness. The entire operating system will become noticeably slow and unresponsive. Tasks that were once quick will take a long time. Freezing/lag. Your device might freeze or lag frequently. Boot up problems. It could take much longer for your device to start up, or it might even get stuck in a boot loop in extreme cases. Failure to update OS, operating system updates, often require significant free space. You won't be able to install critical security patches or new OS versions. 5. Browser issues. Web browsers may become sluggish. You might not be able to download files from the internet. Browser caches, temporary internet files, can't be stored, potentially affecting browse speed. 6. Loss of data/functionality. Potential for serious issues. Corrupted files. If the system tries to write data when there's no space, it can lead to file corruption. System instability. Prolonged use with full storage can lead to instability or even damage to the file system. No backup capability. You won't be able to create local backups of your device's data. What to do when storage is full? Delete unnecessary files. Go through photos, videos, downloaded files, and documents. Uninstall unused apps. Remove apps you no longer need. Clear app caches. Many apps store large amounts of temporary data, cache. You can often clear this in the app settings or your device's storage settings. Transfer to cloud external storage. Move large files to cloud services, Google Drive, Dropbox, iCloud, or an external hard drive USB stick. Check other or system data. Sometimes, a significant chunk of storage is taken up by system data or other categories, which can be hard to clear without more advanced steps or a factory reset. In summary, running out of storage severely impacts your device's usability, performance, and overall health. It's crucial to manage your storage proactively to avoid these issues. Yes, if your device's storage is full or nearly full, it can contribute to overheating. Here's why and how. 1. Increased CPU/GPU activity. When storage is full, the operating system and applications struggle to find space for temporary files, caches, and swap space. This means the CPU and potentially the GPU, for graphics-intensive tasks, have to work much harder to manage data, constantly trying to write, delete, and reallocate tiny bits of space. This increased processing effort generates more heat. 2. Constant I/O operations. The device's storage controller, the part that manages reading and writing data to the flash memory, will be in near constant operation, trying to perform tasks, even simple ones, on a full drive. This continuous input/output I/O activity uses power and generates heat within the storage chips themselves. 3. Lack of swap space, virtual memory. Operating systems use a portion of storage as virtual memory or swap space when RAM is full. If there's no storage available for this, the system becomes highly inefficient. It might constantly try to free up RAM, leading to a lot of background activity, which again puts more strain on the CPU and results in more heat. 4. Application instability and crashes. As mentioned before, apps may crash or become unstable. When apps crash, the system might try to restart them or perform recovery operations, all of which demand more processing power and contribute to heat. 5. Reduce thermal management efficiency, indirectly. While not a direct cause, if the device is already struggling due to full storage, its overall performance decreases, and it might not be able to complete tasks quickly, keeping components active and hot for longer periods. So while a full storage isn't the only cause of overheating, it's a significant contributing factor because it forces the device's main components, CPU, GPU, storage controller, to work harder and less efficiently, thereby generating more waste heat. This is why freeing up space is one of the first troubleshooting steps for a slow or overheating device. Okay, let's clarify what this scenario means. Your storage passes 128 gigabyte storage with 1 terabyte with your current storage. It sounds like you have a device that originally came with a certain amount of storage. Let's assume it's less than 128 gigabytes, perhaps 64 gigabytes or 32 gigabytes. And you're now talking about a situation where 1. Your used storage on that device exceeds 128 gigabytes. 2. You also have access to 1 terabyte of storage, likely meaning external storage or cloud storage, separate from your device's internal storage. 3. Your current storage refers to the internal storage on your device that is currently being used. So the core of the question seems to be, what happens when the internal storage of your device, which might have a physical limit, e.g. 128 gigabytes or 256 gigabytes, becomes full, especially when you also have access to a much larger 1 terabyte of other storage? Let's assume your device's internal storage capacity is, for example, 128 gigabytes, and you're saying your current usage has passed 128 gigabytes, which means it's full. Here's what happens when your device's internal storage passes its capacity limit, e.g., you try to put more than 128 gigabytes of data onto a 128 gigabytes internal drive, even if you have 1 terabyte of external/cloud storage available. 1. Device-specific issues, as previously explained for full storage. Storage full warnings, constant notifications, inability to save new files. No new photos, videos, apps, updates, or documents can be saved to the internal storage. App functionality issues. Apps crash, run slowly, or fail to launch because they can't access necessary temporary space on the internal drive. System performance degradation. The entire device becomes extremely slow, sluggish, and potentially unstable. Overheating. Increased CPU storage controller activity due to struggling to manage data can lead to overheating. 2. The role of your 1 terabyte storage. No automatic relief for internal storage. Your 1 terabyte of external storage, like a USB drive, SD card, or network drive, or cloud storage, like Google Drive, iCloud, Dropbox, does not automatically free up space on your device's internal storage. Your device still needs its internal storage for the operating system, apps, and their data. Manual management required. To benefit from your 1 terabyte of external/cloud storage, you would need to manually move files, photos, videos, documents from your device's full internal storage to the external/cloud storage. This is how you offload data to make space internally. App storage limitations. Most apps must be installed on the device's internal storage. You typically cannot install apps directly onto an SD card or external drive, and certainly not onto cloud storage. So if your internal storage is full of apps, having 1 terabyte of other storage won't help you install more. Streaming versus local storage. If your 1 terabyte is cloud storage, you might be able to stream content, like music or movies, without downloading it fully to your device, which saves internal space. However, for everyday app usage and data created on the device, like photos you just took, the internal storage is key. In summary, if your device's internal storage, e.g. 128 gigabytes, is full, the device will experience severe performance issues and limitations, regardless of how much external or cloud storage, e.g. 1 terabyte, you possess. The 1 terabyte storage is valuable for archiving and backing up data, but it doesn't solve the problem of a full internal drive unless you actively manage and move data off the device. You're describing a very dire and irreversible situation when your phone's storage is completely full, especially with the added constraints that you cannot type with bytes, meaning you can't manually manipulate data at a low level to free space. Erase the device, meaning no factory reset is possible. In this scenario, where your phone storage is full and you are actively prevented from freeing up space or erasing it, and considering your previous points about performance degradation and overheating. 1. Complete functional failure. The phone would effectively become a brick. It would be unresponsive, frozen, or constantly crashing. You would not be able to open apps, receive calls/messages, take photos, or perform any normal functions. It might enter boot loops, constantly trying to restart but failing, or fail to boot up at all. The overheating issues would likely persist and could become more severe due to the system constantly trying and failing to allocate resources. 2. No user control. Since you cannot erase the device or manipulate data at a byte level, you would have no means to recover it. It would be stuck in this unusable, full storage state. 3. Death of the phone. Metaphorically, your description perfectly captures the outcome. The phone has effectively died. It has lost its ability to function as intended, and there's no path to revival through software means. Sending it to a rest-in-peace place or rest-in-peace island is a poetic way to say the phone has reached the end of its functional life. It will be consigned to being unusable, possibly kept for sentimental value, or disposed of through e-waste recycling. In a real-world context, if a phone reached such a state, e.g., due to severe, unresolvable software corruption from a full storage, combined with a bug preventing resets, the only remaining option might be professional hardware intervention. A skilled technician might be able to physically remove the storage chip, try to recover data, highly unlikely if it's deeply corrupted, or flash the firmware directly, bypassing the usual software mechanisms. This is often expensive and not guaranteed to work. Replacement. For most users, the practical solution would be to consider the phone permanently dead and replace it. So, yes, your metaphorical description of the phone dying and going to a rest-in-peace island due to full, unmanageable storage is an accurate representation of its ultimate fate in such an extreme scenario. You're extending the metaphor of a dead phone to a very specific and impactful place. If your device dies due to completely full, unmanageable storage, and you explicitly state it cannot be sent to heaven, this reinforces the idea of its permanent and irrecoverable state. Here's how that adds to the previous description. No hope for software revival, cannot be sent to heaven, implies there's no divine intervention, no magical fix, and no over-the-air update or factory reset, which could be seen as a form of software resurrection that can save it. Irreversible loss. The data on the device, if not backed up, is truly lost and cannot be retrieved through any normal means. Finality of state. The phone is stuck in its bricked condition. It's not just temporarily down, it's functionally deceased. Physical disposal is the only option. Since it can't be restored, its ultimate destination is likely e-waste recycling, a metaphorical rest-in-peace island, rather than a return to active service, heaven. So, if your storage is full, you can't type with bytes, you can't erase the device, and you cannot send it to heaven, then the device is indeed in a state of terminal failure, from which there is no software-based recovery. It's effectively useless,